I think I'm ready.
All right. Dr. Schultz, good day. How are you?
I'm doing well, Kevin. How are you?
Good, good. What value are we going to drip out to the community today? Drip as
Yeah,
in good. Like, let's give good value to the community.
yeah, absolutely. So we're going to do a follow-up to the a video we did here a little while back around the functional architecture within your manufacturing systems. And we're going to talk about how we actually take the master data model, and we'll get into this diagram here shortly, and how we use that and apply it for level 2 systems and what that might look like. And for this example, we're going to take a look at the role-based equipment within the ISA 95 standard, and then what does that look like to actually dynamically create your tag structure within a SCADA platform, and are going to be using Inductive Automation Ignition for that. So that's what we're going to be walking through today.
Why does this matter? Let's start there. Let's back it up. Let's back up the truck a little bit.
Yeah,
Why does this
absolutely.
matter? And to whom as well?
Sure. So the idea of the master data model is, as we've discussed, is that it generally is thought of as something that just sits within a level 4 system. So my ERP is going to manage this master data model, and that'll be the source of truth that everything uses. And it's been very common to where that's where it stops. So your ERP has its master data model, but then any other system, and this is more on the manufacturing side, they don't necessarily subscribe to the idea of we need some kind of master data model. At least historically, that's how it's been. And in the last 5 years, since we started, down the road of the unified namespace concept and the approach, it's we want to start modeling all of our data. And we've generally done that in the system that, whatever we worked on, that's where we're going to start creating these data models themselves. And that's all well and good until you realize these data models are going to be used by other systems. In this case, both level, your level 4, your level 3, and your level 2 systems. So for instance, currently working with a client, they have their data model is being done in one particular software, and they're moving away from that software. They've now decided to do it in a second software package. And the recommendation that we've provided is you should really do that in this master data model so that any system can consume from it, and you're not reliant upon one piece of software. Remember, one of the adages is we want to integrate our intelligence into technology, not into systems, solutions, infrastructure, those types of things. So the master data model, it's abstracted, it sits on its own. In this particular case, we're going to use a SQL database, but now any system that wants to consume it can go hit that database. We're not relying on a piece of software to do it. And then there's only one place that if you want to do versioning and updates, then you can make those changes in one place, let the other systems know there's a new version available, and then you can apply your business logic, your business processes to when do you update these types of things. So that's really why it matters. It makes us more flexible and scalable. It also does create that single source of truth for all of the data models that exist throughout the organization.
The last part there is you said it. So, in my own words, we're a manufacturing company. We've adopted this approach, this concept of the unified namespace. We like it. That then tells us we need to model stuff, model
Mhm.
at the edge, model. But we also know that systems will change, and we want to then be able to use those models in multiple systems, not just now, but in the future.
Mhm.
Therefore, we should be abstracting the model out of each of those systems to another system where those systems then can consume that data. So in the UNS, we're not only consuming data from the edge, all the different systems, devices in the plant and data systems as well, but we're also consuming the model, the
Mhm.
master
Yeah.
data model effectively.
Yeah.
So then
Yeah.
you're
Exactly.
putting that data model at a different abstracted level. Then any one of those systems should be able to, if we're following our minimum technical requirements, they should be able to pull this model and then start to use it and consume it. And also, as I think you've already said, we can then modify that model, that master data model, and each of those systems can then update based on that model.
Yeah.
All right. So
Absolutely. That's
who
exactly what we're going to do.
who's going to
Go
care
ahead.
the most about this?
So this is
What
really
roles?
data governance. So really, I mean, anybody that's involved in data is going to care about this because if, going back to that diagram, and I'll bring it up here shortly, it's that if you're the data scientist, you're the architect of all this information, if you know what the data is going to look like coming in, that just makes your job that much easier for people that are sitting at the plant floor. It helps them optimize what it is that they're doing, because I can start comparing like for like equipment anywhere across the enterprise. And it makes it easier for you to scale out and even extend the solutions. So remember another adage. Yes, there's data governance. It's the thou shalt, you will have this, but you can also extend it and add on, whatever it is that you want. I worked for a company one time, and he said, now you can put you can put your little decorative thingy on the mirror and the mud flaps on. It's still, at the end of the day, it's a car, but it does allow you to meet that. But as far as who's going to care, everyone in the organization is going to care as companies become more data-driven organizations, especially manufacturing.
Sure. And to be fair, though, to the people who will care the most, I think, is anybody involved in those data integrations. It's
Absolutely.
the people on the OT side that are doing the technical work. For us, often is the manufacturing engineers, process engineers, sometimes controls engineers, automation people. And then on the IT side, anybody involved in that data governance, data models, et cetera. And also IT directors that are making decisions on these kinds of products, and a few other people. Okay, great,
Yeah,
awesome.
quick ways, anybody that's involved with data, and that's a pretty broad brush anymore. I mean,
Right,
that's going to be the nature of it. So
sure, okay. And if I remember correctly, I remember there's some good ERD, some entity relationship diagrams. I love my good ERD, so let's
yeah,
get
there
rolling. I
are.
want to see it.
All right, there are. So let's go ahead and start off with I know you just mentioned those. We're going to come back to
Please.
them. Yeah, so let's start off with this functional architecture. And when I first used this, it was the idea of these are the types of systems that are going to exist within a manufacturing environment. This is the nature of how they exchange their information and how they all persist their information. You'll notice that there's different types of storage, there's different types of the exchange mechanisms, but in large, this is really where you're going to start from. It's meant to be very abstract and high level. So I have this master data model. It's sitting as a level 4 system, and as we mentioned last time, and when we were getting into the video, most commonly this is going to apply for your ERP. But you want to take the same concept of the master data model and start applying it down into your level 3 systems. So we were talking a little bit before the call about, oh, these are going to be like your process segments and your operations definition segments. Yeah, absolutely. You're eventually going to want to model those as well. So regardless of what your level 3 systems are for your manufacturing operations management domain, they're all going to have the same common understanding of this is how we make stuff in this plant. For today, we're going to look at the equipment. So that's one of your resource models from the ISA 95 standard. And we're going to look at the equipment or role-based equipment. And this is something that it performs a certain function is what we mean by a role-based equipment. So the function or the application here is taking master data model, and we're going to create a master data model that can be used by a level 2 system. And of course, we're going to use Inductive Automation Ignition for this. It happens to be one of the platforms that we use, and we're very fond of using because it allows us to do a lot of things. So far, so
Again,
good?
yeah. So again, the idea is Ignition is new. We were on something else. The idea is that hopefully that other system was able to consume from this master data model. Now we're going to consume that into Ignition to be able to use it.
Yeah, exactly.
And then it
Exactly.
makes that process of transition so much faster.
Yeah,
Yeah,
exactly. Because, as we were talking earlier, who cares about this? Well, anybody that's involved anywhere in this data loop is going to want to know, what does this model look like? What have we agreed on that all the things, not just our resources and our assets, but our overall process, what does that look like? So we can start understanding and make decisions based on that. A lot of your data scientists that are involved in these projects, a lot of what they have to do is cleanse the data first. But if we can start with an agreed upon way of this is what our data is going to look like and how it's structured, makes that so much easier. And as we exponentially increase the intelligence within our factory, this is going to become more and more common.
awesome. Let's keep going.
Cool. So what I've done here is created a very basic rudimentary database schema. So please don't grade me on my database schema type stuff. I've tossed in some things that are fairly common. Something that's missing here probably is some versioning. Typically we'll use or what is the effective date is another one, effective, now, effective in the future type of thing. So there's a lot of ways you can go about it. But first, let's start about the equipment. So as I mentioned, this is your role-based equipment. These are, these are systems in your plant. Typically we were, think of the equipment as the role-based hierarchy. We have the enterprise site area line. So think of equipment as a line, or it could be a cell, depending on what type of manufacturing you're doing. But we're going to have an equipment, and this is the thing that we're going to model. Within the ISA 95 standard, when you have an equipment, so of course there's equipment classes and there's instance of those classes that we'll just call equipment, but you have properties. And properties are going to describe certain features about that equipment that we want other systems to know. So say, for instance, I'm a storage unit, I might have a material of construction. I might have a capacity. So those are just things that are static about the equipment. And the same thing is going to apply for, your filling lines or any other, again, the role-based equipment that is in your particular factory. But there's also going to be properties that are going to be used for exchanging of information. So if you think about, I have my set points and I have my actuals, those are where we're going to be doing exchange. So those types of properties are going to exist on that piece of equipment as well. So not only do we know, say, the faceplate information of this equipment, we also know what's the type of data we're going to be interacting with on a regular basis. What are the set points we're going to be providing for the equipment and that type of thing. So does that make sense of the the equipment and the equipment property?
Yes, it does.
Okay. So rather than enumerating all those properties as part of the model or as part of the within the data property description itself, what we're going to do is, in this case, we're going to assign a data type, which is going to be the model that the data model that this equipment will use for defining its equipment property. So this data type will have all of the properties that are associated with the piece of equipment that we're looking at. So again, rather than enumerating all those, we're going to build a model so that every instance of that equipment anywhere within our enterprise, we can say that this type of equipment is going to have this type of, the value string is what I've used as the foreign key, and then it's all going to tie back to this data type. So, since we're using Ignition, the data type here will be a UDT.
So that
then,
is
go ahead.
where does the if you were to think about the Ignition concept, the UDT, where does the UDT essentially exist? The UDT would then be created. The highest level aspect of the UDT will come from where in these tables?
Oh, so the UDT definition itself will be made up of, this is the data type. So this is going to be the name of the UDT. And then we're also going to get in this data type property. So much like equipment has equipment properties, our data type is going to have a data type property. So we're going to have that tied back to that same primary key. And then we're, of course, going to have a data type property ID. It's in this data type property table that's where we're going to define all of the parameters and all of the tags that are associated with that data type, so that when you instantiate this data type, you already know the information that's there. When this equipment is instantiated, it's also going to have the equipment properties that are based upon this data type that we have referenced in that master data. Now, I mentioned this was rudimentary. There's a lot more you can do with this data type property. There could be a data type property table that for every one of these data type property IDs, we're also going to list. So we'll use that UDT as an example of, what's the source, what actual PLC address are we mapping to? What's its type? Is this a memory tag? Is this an OPC tag? Those types of things will all get ferreted out, but I wanted to keep this very basic and very simple just so people could follow along. But the idea, the concept is that this is the type of information that I'm going to start collecting, organizing, and putting together and building a standard around. So, again, anybody that's interested in using these models anywhere within the entire, all that functional architecture we had, we're all going to agree upon what this is going to look like.
Fair. Okay, understood. So this is where the source of this is the source structure for this abstraction that you're going to create.
Exactly. So, real fast, we're going to create a master data model, going to be consumed by our level 2, our SCADA system in this case. I've put together a very simple database schema that is going to be the source of the information that Ignition is going to use to create its equipment model within the tag structure itself. Just as a caveat right now, you're not able to script the creation of UDTs, so I have had to create these. So this is more of a specification of how you go about building the UDTs. But once that's done, then you can instantiate it as needed. So just want to make sure people are aware of that this isn't scripting the whole thing. It's just taking, I've used this as a reference and a standard for building those data types or those UDTs and the properties that are associated with that.
Okay. All right. I think
Cool.
we get, then to the data, to actually look at the data that's in those tables, right?
Absolutely. So now let's take a look at building out. So I've built in that database schema. So I've actually gone into my database. This is all going to be done in Microsoft SQL. So I've started off by, let's talk about what does that equipment look like. So the first step in doing that model is I want to populate that equipment table of what is all of the equipment that exists within this organization. So if you remember the another video we did here recently that was on the movement of materials, I've done something very similar here where we're going to have the enterprise, the site, in the area. And then I've gone through and created all the work centers, all of the storage zones, all the storage units that are associated with that. I've given an equipment ID. So if you remember going back to that database schema, this is going to be the primary key that everything is going to relate to. And then, of course, if there's a parent ID, so I understand some of the relationships of it, I've also built that model in, or that column is built into this table. So we start understanding what's the hierarchy of this overall equipment look like. So here's the information that I've built in there. You can just take a look at it. So this is what it'll look like. Next step is to actually build or tie the models that we're going to apply. So going back to that database schema, now it's going to have this foreign key of, okay, so for this type of equipment, and this is equipment ID that I'm going to relate back to my equipment table, what exists here, what type of model do I want to use for my LGV agent? What type of model do I want to use for my storage zone storage unit? And this is where I've created a description. There's a type ID. This value string is going to tie back to the actual. This is the type of equipment that's here. Again, this is very basic. There could be dozens of models that they could take on because you might have storage units that have different needs. So you're going to model them a little bit differently. But this is how you're now going to take your equipment and you're going to tie to how am I now going to model this equipment for any system that exists within the enterprise.
So is that value string essentially the name of the UDT?
Yes, that's exactly what the name of that UDT will be as a UDT. Of course, when you instantiate it, it's just going to be the name of whatever that equipment is. And that'll make a little more sense when you see that.
Okay.
So now I've created the actual data types themselves. So you can see I have that data type ID. We're going back to the equipment property. I've created these, we'll just call them the UDTs. So this is actually what you'll see. And you can, what I've done here is actually created where's the path to get to this model? Where is it in its overall organizational structure? So, there's a little bit of hand waving here. I did make this somewhat specific for Ignition to make the demo work, but this is the type of information that you would want to include in an abstract way that any system could consume and know exactly where to get it. So, in some ways you could say, well, this is how I'm now going to organize it. So whenever I have a data model, regardless of what it looks like in the system, this is how I'm going to organize the actual, models within that particular system itself. So that's what I've done here. That's what's pointing to it. And then finally, filling out the last of the data tables. This is where I'm now going to take all of those UDTs or those data types, and I'm going to assign what are the parameters and what are the tags associated with it. If you remember back to the material movement video that we did, you're going to see, well, here's that LGV. Here's my asset ID and my equipment ID. And then now I'm going to have all the tags, battery, where am I, coordinate X, Y, where am I going, what's the job order that I'm working against, et cetera, et cetera. So for all of the role-based equipment that we've defined in this particular plant, I now have a data type ID and all the properties that are associated with it. Again, this would be more of a specification for how I'm going to build the UDTs or the models. within that level 2 system, but this is how they're going to be organized and this is what they're going to be called. And then we're going to have parameters and tags associated with it. So starting with, we're going to create master ID. We have a database schema. Now we're going to populate all the tables for, this is what our plant looks like. This is the properties that's associated with that equipment ID. Then we're going to do the same thing with, here are the data types that I've used to create those data models. And now here are the properties that are associated with it. These are the things that I need to know about. So I'll pause real fast there. Go ahead.
Yeah, so we've seen the equipment table, which is the equipment model, which includes enterprise site, area, work center, work unit, all of those pieces. Then we moved to break that down, into the next. And this is then starting to define another layer of that structure. Then the next is, so I then struggle, apologies. The next one is where we define the UDTs. I'm trying.
Sure.
Oh no, this is the list. The value strings are the names of the UDTs there, and then keep going. Sorry.
Yeah. Oh, go ahead. Go ahead. You're doing great. So yes, we're going to decide for this particular equipment, this is how we want to model it, or this is the model that we want to use for this type of equipment.
Right. Okay. Right. All right. And then you're defining that UDT here, and then all the properties with the tags in the final table.
Correct. Exactly.
Or the properties, which are the tags, effectively.
Yeah, which would be the tags, and the parameters are going to be associated with those UDTs. It's something that we're going to populate.
Yeah.
So, awesome. So that's how we're going about it. And yeah, it did take a little bit of time to create this, but when you're doing this in practice, you're going to export into some type of, a CSV, or can I export that to Excel? Yeah, you can. And then you can start adding in a lot of these things very quickly. This comes together a lot faster than you would think, because even though it's just this very small, it's like, oh my gosh, I've already up to 40 lines within this table, and I'm only done some basic equipment modeling. Yes, again, good practices. You might want to start separating these out so it doesn't become so ominous. But there's a very quick way to go about creating these equipment models.
And it wouldn't be difficult to create a UI to create this too if you're not already pulling it out of your ERP or your MDM tool or whatever it is.
Yeah, I mean, you're going to want to do this programmatically. As I say, don't do something in a rote method in 8 hours that you can do programmatically at 24.
Yeah, exactly.
Because even though it takes you 3 times as long, you get to look back and go, I'm a genius. Look at that code I just created, right? Yeah. Exactly.
Well, let's perfect. Code now that you talk about it.
Cool. So let's go into the last piece. This is going to be the ignition itself. So as I mentioned, I've created the UDTs already in Ignition. There's not a way to do that programmatically yet, but I've now followed that same pattern of, I've created my equipment folder where I'm going to have all of the names of the UDTs. So I have my agent, and I just, as a practice, I always called something core, because that meant it's the base unit of this UDT. And then if you want to extend that tag, then you just use the core as your root. So you can call it core, root, base, anything else. Just my practice is to use core. So now I can extend it out if I need to. So I can use this as again, with UDTs and many other systems that are doing these models, you can use something as its base and then build upon that. And that's part of that data governance. It will have this, but you can build off of that as well.
And that a good example of that is a plant that we were working with a bunch of CNC machines, 2 OEMs, multiple models for each OEM. We had a core CNC model. Then we inherited that to create the 2 different core models, if you will, for the 2 different OEMs. And then all of the models from there, each of them had slightly different arrangements for tags. And so then we inherited from that to create those UDTs as well. But there was that core, literally and figuratively, that core central CNC model that we started with, that had all of the very basic tags that a CNC should in that shop, at least.
Absolutely. And that becomes the, as I mentioned earlier, you can, put the little, whatever your little decorative device hanging from your rear view mirror is, and mud flaps and pinstripes and all the things that you need to do to yours. But at the end of the day, there is a base model from which you're going to build everything. So just demonstrating that I do have to build these in. Ideally, this would be done programmatically. These UDTs would be updated per the model that's in that SQL database table. But in this case, this is the manual exercise. But you only have to create those models once. Then you can instantiate as many as your little heart desires.
Awesome.
So finally, we'll bring in the last of the magic. You can see here within my master data tag provider, I have no definition because I have built all of this programmatically in something that I can now go query. It becomes a very easy way. Again, this is a SQL query, but ideally you'd want to have it be some kind of API that gives you the ability to, select different aspects of things. But, just for, the sake of this is what we're doing, it's going to the database of that I call master data. There's a very quick query that's been built. I execute that script, and then I go through that result and I parse the data, assigning, I have my equipment ID, my scope, my type ID, tag name. So you asked earlier the UDT name. Yes, that would be that type ID. But when I instantiate it, I'm going to call it something different. That's one of the values that was in the equipment property itself. And then I'm really just creating the instance of that UDT. I'm here at the very last part. And if this is working, we're now going to execute. And now you can see that I've built out my full equipment hierarchy that has all the mobile equipment in here. And I've instantiated everything that needs to be there. Now, if you did notice or did watch the material movement video, you'll notice there are some tags that are missing, and that's okay. And that's something that would be modeled in the future as well. Didn't here in this particular case, but the point is that you now have that data governance of all your equipment's now been defined. We know exactly what's going to be on each LGV, what's going to be on each LGV agent. That's all been there, and it's just a matter of you getting these connected in and that type of thing. But any changes that I would need to make in the future, you can run some kind of business logic or a formal business process for getting it updated. So say in the case of Ignition, I might decide my EAM, that's my enterprise, that's going to be the device or the platform or the gateway that's going to query that master data model. And then there'll be some logic around when do we deploy that to all of the sites that the EAM supporting. An advantage of that is now instead of having just one source of that master data model, we actually have a distributed model for all of the data that exists out there as well. So a lot of advantages, but really the takeaway here is that we've abstracted it. It's a level 4. Any system that we want or needs this type of model can consume it. It's data governance. It's one place to manage everything and do all that versioning. And then it's just a matter of having all the other systems that consume it, again, have some kind of business logic or business process that will do it. But you can see that if you take the work and do it up front, makes it very easy to create this type of infrastructure in the field itself in the future.
Awesome. The way I think about this is that we're, using my words, kind of repeating some of what you said. We're setting the model, the universal model across the organization. We're establishing it. The master data model is already that in concept. It's been around for a long time, but we're now using it, not just in the ERP system, but the other systems as well. Some companies are able to do that with their EAMs, et cetera, but now we're using it even more across the organization. So we've adopted this UNS approach, et cetera, to use it. And we know now that we have to model, kind of saying the same thing as I said before, just to clarify. Now we're going to make it easier to adopt this model into new systems if we have to use it. And then once we're doing that, we are now getting everyone to sing from the same hymnal.
Yeah,
Effectively.
exactly.
We're reducing the time to decisions for data, like in the very end, reducing the time to decisions for data by getting these new systems in faster, increasing the value of the information even more. So it's there's a ton of benefits. And this really, as you had said, matters to everyone using data, which is pretty much everybody. I think about in more discrete terms, IT, automation, the people getting their dirt under their fingernails doing this kind of work. Those are the people that really care about this. Like, let's save me a heck of a lot of time so I can get the system up and running faster so that I can move on to the next project to get
exactly.
right data to the right people.
Yeah, and if you plan, I mean, this is where we start getting into trouble is, through acquisition, merger and acquisition type activities. Now, if you're into a new plant that has all different software, well, that's okay. We already know what our core system looks like, and it's just a matter of getting that system that you've acquired aligned with what do our data models look like. And it's super fast. It's like a lot of things. It's like cooking Thanksgiving dinner. There's a lot of work up front, but man, when you sit down to eat with your family, man, that food tastes super good.
Yeah, I mean, and this is the kind of conversation we're having more and more with companies that have gone through lots of acquisitions. and they have to integrate these companies, not just integrate data in the plant, but integrate the companies together. Bunch of ERP systems, then out pops this sub-industry called model data management to manage the data models across organizations, across multiple ERPs. And as those ERPs improve and as the MDM arena improves, we can start to get into this kind of idea too, to make those integrations of companies even faster as well.
Yeah, so I think a logical next step in this would be, let's take a look at doing some process modeling itself, so that there's agreed upon. Now we know what our equipment looks like. How do we actually go about making it? And I think that's going to be a topic for a future podcast, where, again, equipment models, it's static. We kind of get it. What does this look like if we need to do something more at that level 3 arena? So it'll be just a preview of coming attractions.
Good. Awesome. All right. I think that's it.
Yeah,
Cool.
I agree. This is kind of a shorter one for us, which is, that's a little unusual. We usually have a lot more to say about things, but I think that's good. It's a pretty basic concept, but it's very powerful.
Yeah, good. All right. Thank you all. Like, subscribe. We'll be back.
All right. See you, Kevin.
All right. That was good. Thank you. Awesome.